So yesterday we started a topic which is related to methods of purification. So we discussed different techniques depending on the type of the mixture we have. The first one which we discussed, the technique that was filtration. So in what cases we can use filtration? Filtration can be used to separate the insoluble solid or the undissolved solid from the mixture. So if you want to separate insoluble solid or undissolved solid from the mixture, what we can do, or we can use this technique called filtration. Like example, if you have sand mixed with water, or you have extra salt is there in water which does not dissolve, so you can simply carry out this technique of filtration. Decanting, the same way, a decanting can also be used to separate the insoluble solid from or the extra solid from the mixture. But in this case, we pour the liquid out from the mixture. So it is a fast process in terms of separation, but it is not 100% accurate as compared to that of filtration. Filtration will take time, but it is an accurate process. If you want to separate the insoluble, very fine or very small insoluble particles from the mixture, what we can do, we can use centrifuging. So in a centrifuging, we move the content in the container or a flask or a tube at a very high speed, so the particles will experience force and they move to one end of a tube, so it is separated from the liquid. So we can simply decant, or again we can use filtration to separate the liquid from solid. But normally this technique is used for very fine particles which remain suspended, does not settle down quickly. So we move at a very high speed, which cause the particles to be at one place, and then we can use decanting to remove the liquid from the solid. So these cases are used to separate the insoluble solid from the mixture. But if you want to separate a soluble solid, a solid which is dissolved in a solvent, it make a solution, then what we can use evaporation. So what we do in evaporation, a salt is dissolved here, a substance is dissolved in water. So when we supply heat energy, the water will escape. So as the water will escape, the left behind the residue will be the salt. This technique takes time because we have to wait until all of the liquid evaporates or until all of the liquid changes into vapor and we are left behind with solid. So what else we can use is, other than evaporation, we can also use crystallization. So what we do in crystallization, first we heat and concentrate the solution. Heat and concentrate the solution means that solution volume is decreased. Then we cool down the solution. When we cool down the solution, so we have crystals formed and we can use a filtration. When we use a filtration, we can separate the solid from the mixture, and this is just to check the melting point. This technique is mentioned, but simply what we can do, we can use a crystallization. In crystallization, we don't evaporate all of the liquid, we just evaporate or remove small quantity of the liquid. So this is what we have discussed yesterday, and we did one question related to that part as well. Then simple distillation. What is a meaning of a simple distillation? Example, in evaporation or crystallization, we want a salt or we want a solid from the mixture. But example, if we want a liquid from the mixture, so in that case we can use simple distillation. So simple distillation, it is used to separate liquid or the solvent from the mixture. How a solvent or a liquid is separated from the mixture? This technique is called simple distillation. So basically what happened, example, you have a salt water. So salt water means a salt is dissolved in it. It's a clear solution. So when you supply the heat energy, the water water in a liquid state will turn into vapors. So these water vapors, the black spots are representing the water vapors. So these water vapors will rise, and what we have here, this is called a condenser. What is the purpose of the condenser? The purpose of the condenser is to remove the heat energy from the water vapors or cool down the vapors so they turn into liquid state. So when you supply the heat energy to a salt solution, like here we have a salt solution, we supply heat energy. So this water will evaporate or it will form water vapors. When it form water vapors, these water vapors, as they rise, because it is hot, hot vapors always rise up. So as they're rising, they're losing some of the energy, but still in the vapor form. When they enter this part, this is called a condenser. So when they enter this condenser, the condenser, inside the condenser, there is a water moving, water is flowing. What is the advantage of this water? This water will absorb the heat energy from the water vapors. Like water will enter from here and it will escape from this side. What is the advantage of this cooling water? When this cooling water is flowing through the condenser, it will absorb the energy from the water vapors, and when it will absorb the energy from the water vapors, these water vapors will condense or it will turn into a liquid state. And what we have here, we have a pure water, which is also called a distillate. So in this technique, we collect the water after first we evaporate and then we condense, so that we collect the water, and this will be a pure water because the salt will not vaporize, the salt will left here. Once all of the water evaporated, the salt will be left in the left hand side, and what we collect here will collect a pure water on the right hand side. So the purpose of the condenser is to remove the heat energy from the water vapor, so it will convert the water vapors into liquid state. Is it clear? The concept of simple distillation, a technique which is used to collect the water or the solvent from the mixture. So if we want water from the salt solution, we use this technique. Any doubt in this part?
Sir, excuse me.
Yes.
Sir, what's the distillation flask used for? I didn't understand it well.
The distillation flask, it is used to, it's a round bottom flask. It is used to to have a mixture in it. In a distillation flask, what we have a mixture. What mixture? Example, we have a salt water or a salt solution. So the
Okay.
purpose of the distillation flask is to hold the mixture. But when you supply heat energy, so when you are supplying heat energy, what will happen? The water will turn into vapors. The salt will not turn into vapor, the salt will left behind, and the water will turn into vapors. As this water turn
Okay.
into vapor, it enter a region called a condenser. What is the purpose of the condenser? Inside the condenser, there is a cooling water. What is the purpose of this cooling water? Because the water has a tendency to absorb the heat energy. That's why, like example, in a
Okay.
car radiator, you are adding water inside a car radiator. What is the purpose of that water? It's to cool down the engine. Because when a water is flowing through the car engine, the sides of the engine, then it is absorbing the heat energy from the engine so that engine will not be too hot.
Okay,
When
sir.
this cooling water is flowing through a condenser, it removes the heat energy from the water vapors. As it removes the heat energy from the water vapors, so these water vapor will turn into a liquid state, and what we collect here, we collect a pure water. So if we want to separate the liquid or a solvent from the mixture, we use simple distillation.
Okay, sir.
Is it clear to
Yes,
everyone?
sir. Thank you so much. Yes.
Okay. You can use a mic or a chat if you have any question or a doubt. So you have to learn the labels as well. Like sometime in exam, normally in paper 6, they ask label the apparatus. So if it is pointed at this one, this is a thermometer, distillation flask, a mixture or a salt water, heat. How we can supply a heat energy? There are different ways to supply the heat energy. We can use a Bunsen burner, or we can use electrical heater. So both of them can be used to supply the heat energy. But when you are using the Bunsen burner, flames will be there. You can see the flames. But when you are using an electrical heater, it's by electricity it is generating a heat energy, so it is not producing any flames. So for example, if we are heating any liquid which can catch fire, like for example a mixture is there inside the distillation flask which can catch fire, so which one is a suitable heating apparatus, a Bunsen burner or electrical heater? If a liquid can catch fire, or if it's a flammable liquid, then which one is a suitable heating apparatus, a Bunsen burner or an electrical heater? Yes. So in that case, electrical heater is suitable. Why electrical heater is suitable? Because electrical heater does not produce any flame. So if it does not produce any flame, the liquid less likely it will be dangerous, or the liquid cannot catch fire, because if a liquid is exposed to the flames, it can catch fire, as some of the liquids are flammable. But in case of water, like you have water here, water is not a flammable liquid, you cannot burn it, so you can use any of them. But some organic compounds such as alcohols, they can catch fire. So if you are heating a mixture which is having alcohol, then for a safety purpose, we always prefer to heat with electrical heater. Is it clear, the concept of simple distillation? The process of boiling the liquid and then condensing the vapors produced back into liquid state is used to purify the liquid from the mixture. So basically, as you can see, when we are supplying heat energy, the liquid will vaporize, and this is a condenser. So the condenser, what it will do, it will remove the heat energy from the vapors. So as it remove the heat energy from the vapors, so what we collect a sample of water, and that will be a pure water. Now if we want to separate two or more liquids, so if we are separating liquids from each other, we have to check whether they are miscible liquids or immiscible liquids. Miscible liquid means the liquids which completely mix with each other and form a homogeneous layer. The term homo here refers to same. So homogeneous layer means same layer. Like example, if you are mixing water with alcohol. So when you mix water with alcohol, water is colorless, alcohol is also colorless. So when you are mixing water with alcohol, both are colorless liquids. So if you have a container and you mix both of them together, so the mixture will appear as one. Like you cannot say which parts you have alcohol and which part you have water. So this type of a mixture in which we have same layer, this type of a mixture is known as a homogeneous mixture, and the liquids are known as miscible liquids, like liquids completely mixed with each other. You cannot distinguish the two or more liquids from each other. But if you mix oil with water, so when you're mixing oil with water, what you find, you can perform this at home as well. You can take a container, first fill this, like take a glass, fill it half with water, and then add oil, a small quantity of oil. So when you add a small quantity of oil, you can see the two layers. So when you are able to see the two layers, this type of a mixture in which we are able to see two layers or more layers, the liquids are actually not mixing with each other. So this type of a liquid is known as, or this type of a mixture of a liquid is known as immiscible liquids. So when the layers are there between the liquids, we call immiscible. If there are no layers between the liquid, it appear as one substance, we call that as miscible liquids. Is it clear the difference between miscible and immiscible liquids? The liquids which does not mix with each other, and we can see the portion where the two liquids are existing, we call that as immiscible. The term im here refers to not, so they are not able to mix with each other. That's why we call immiscible. But when we mix two or more liquids and it appear as one, then we call that as a miscible liquid. Like it appear as one phase. So another example of a miscible liquid, like crude oil. Crude oil appear to be dark brown or black in color, but actually what is crude oil? Crude oil is a mixture of different substances such as bitumen, fuel oil, kerosene, petrol, or gasoline it's also called, and diesel. So when these substances, these are different types of oils: bitumen, fuel oil, kerosene, petrol, diesel. But when they mix with each other, how it appear? It appear as a dark in color. So is appear as one substance. So when it is appearing as one substance, what we call this, we call that mixture as a miscible liquid. But when oil is mixed with water, it appears as two separate layers between the, like it appear as we know which region we have water and which region we have oil. So it does not mix with each other, and we call them as immiscible liquids. So when we are selecting a technique to separate the miscible or immiscible liquid, we have to first check whether the liquids are miscible or immiscible. Example, if it is an immiscible liquid, the technique which we use to separate the immiscible liquid, that is called separating funnel. And if we want to separate the miscible liquids from each other, the technique is called fractional distillation. So to separate miscible liquids, miscible substances from each other, we use fractional distillation. To separate immiscible liquids, liquid which does not mix with each other, we use separating funnel. So first, what is separating funnel? This is a simple separating funnel. What happened in the separating funnel? This is how the separating funnel looks like. So you can clearly see a mixture At the top side you have oil. Here you have oil, and at the bottom you have water. And what is the reason why oil is at the top and water is at the bottom? Because oil is having a low density. The term density means like number of the particle in a unit volume for oil is less as compared to that of water. So oil will remain at the top and the water will remain at the bottom. Then what we do, here is a tap. So when we open the tap, so we run down the water. As we run down the water, until all of the water is removed from the mixture. So once all of the water removed from the mixture, so what we have here, we will have only oil and we will have water inside the conical flask. So this is a technique which we use to separate insoluble or immiscible liquids from each other. Is it clear? The separating funnel. So the name of this apparatus is called separating funnel, as well as this technique is also known as separating funnel. Is it clear to everyone? Separating funnel, what is separating funnel? It is used to separate two or more immiscible liquids. The term immiscible means that liquids which does not mix with each other, we call immiscible. So you have a mixture. Example, you have a mixture of water and oil. So this one is oil and at the bottom you have water. Now what you do, how to separate this? You transfer them into a separating funnel. So when you transfer them into separating funnel, I am drawing a rough diagram for the separating funnel. At the bottom of a separating funnel, there is a tap. So when you transfer this mixture of water and oil, so water will be there at the bottom. And you will have oil at the top. So when you open the tap, when you open this tap, the water will come down. As this water will come down, so oil will take position of the water as the water run down. So in the container at near the tap or conical flask, the conical flask will be filled with water, and once you reach this point, like the oil reaches the tap, you will switch or you will close the tap. So when you close the tap, now this will have only oil. So you separate the two substances from each other. This technique we call that as a separating funnel. Is it clear now? Yes, Abdullah Sarfraz. Like when you open the tap, you can see the water is coming down, so the level will decrease. Oil will, when you reach, the oil will reach the tap, we'll close this tap. So in the separating funnel, we are left with oil, and in a conical flask, we are left with water. Yes, Abdullah. Any doubt? Is it clear to everyone? So if we want to separate, yeah, it won't mix because as I mentioned, this technique is used to separate immiscible liquid. The term immiscible means that liquids which does not mix with each other. So if you want to separate the immiscible liquids from each other, you can use a separating funnel. So once when we open the tap here, when we open this tap, the water will come down. Once all of the water is removed from the tap, we have to close the tap so that it is left with oil. Like when you open the tap, water is coming down, oil level is going down here. Once oil reaches the tap, you will close the tap. So in the conical flask, you are left with water, and in the funnel, you are left with oil. So this is a technique which we normally use for accuracy. To improve the accuracy, you repeat again and again. So until you have all of water in a one container and oil in another container. So you can repeat the procedure again and again until you have water and oil completely separated from each other. Then fractional distillation. The term fractional distillation, it is used to separate the insoluble solids. So if we want to separate the miscible liquids from each other, what we use this technique called fractional distillation. Example, if you have a mixture of water and alcohol such as ethanol, what is the boiling temperature of the water? The pure water boils at 100. What is the boiling temperature of alcohol? The boiling temperature of alcohol is 78. Ethanol here. Okay. Different alcohols have different boiling temperature, but for ethanol it is 78. Now what we are doing, we are supplying the heat energy. So when we supply the heat energy, we have a mixture of, it's a miscible liquid. So if we want to separate the miscible liquids from each other, we can use a technique that is known as fractional distillation. So here you have a mixture of water. So water I will represent with red, or alcohol I will represent with red. So you have a mixture of water and alcohol such as ethanol. Now when you are supplying the heat energy, which one of them will convert into vapor first? You're supplying heat energy. Which one of them will vaporize first? Ethanol or water? The boiling temperature of water is 100 and the boiling temperature of ethanol is 78. Ethanol is having low boiling point. So ethanol is having low boiling point, so it can easily vaporize as compared to water. So what happened? When we are supplying heat energy, this ethanol vapors will rise. This part is known as a fractionating column, but as these vapors are rising, they lose some of their energy. When they lose their energy, they convert back into a liquid state and then return back. But we are continuously supplying energy, so more ethanol will get energy, it will rise, and then it will return back. Then we further supply energy, it will rise and then return back. Again it will rise. Once the ethanol reach this part, now it cannot lose energy, because in a fractionating column there was glass rod, so it was losing energy to this glass rod. But once these ethanol vapors have enough energy, so they rise up. So when these ethanol vapors will rise up, again we use a condenser here. So what is the purpose of the condenser? The condenser is used to remove the heat energy from the vapors. So inside a condenser, the water is moving. This water will absorb heat energy from alcohol. So when it will absorb heat energy from this alcohol or ethanol, so this ethanol will lose energy and it will convert into liquid state. So what we get here, we get a pure ethanol at this point, which is known as distillate. But what happened to water? because the temperature or boiling temperature of the water is high, more than alcohol. So water need more energy. Water vapors may rise, but they are not able to pass through because they need greater amount of energy. So when we have two miscible liquids, we separate them on the basis of the boiling point. The liquid which is having low boiling point will rise. So the liquid which is having a low boiling point will rise, and the liquid with a high boiling point will remain in the flask. So in this case, we have alcohol and water. Alcohol boiling temperature is lower, so they will rise and then condense. So we collect here, what we collect here, we collect alcohol. Is it clear? The fractional distillation, the concept of the fractional distillation, the process used to separate, in this technique we used to separate two or more miscible liquids on the basis of the boiling point. So when two or more liquids are there, they have different boiling points. The liquid with a low boiling point will vaporize and condense, and the liquid with a high boiling point will remain in the flask, distillation flask. So the two liquids are separated from each other. Example, another example, if I say I was having two substances, not ethanol or water. Now we have, say, butanol and hexanol. Example, the boiling temperature of butanol is 155 and the boiling temperature of hexanol is 178. Now, which substance we collect here, butanol or hexanol, as a distillate? What will be the substance here as a distillate? So we will have butanol here, and hexanol will left in this distillation flask. Why? Because hexanol is having a high boiling point. So substance with a high boiling point will remain in the flask, whereas substance with a low boiling point will rise. So when butanol will rise, it will condense and we collect butanol. And what happened to hexanol? Hexanol will rise, but because the temperature, it need very high temperature to rise and remain in a liquid vapor form, so it will return back into the flask. You have to learn these labels. Here normally we place a thermometer, distillation flask. This is this substance is known as distillate. Both butanol and hexanol are flammable liquids. So if they are flammable liquid, then which is should be the heat source, a Bunsen burner or electrical heater? How we should supply the heat energy, by using a Bunsen burner or electrical heater? So it should be electrical heater. Why electrical heater? Because with electrical heater, it is not exposed to the flame, so it cannot catch fire. Is it clear? The techniques, the separating techniques. So a quick revision, what we have discussed till now. Example, if you want to separate insoluble solid or undissolved solid from mixture, and I will give example for each. If I say example, we want to separate sand from water. We want to separate silver chloride precipitate. The term precipitate is used for a solid which is formed when two solutions are mixed together. This is a scientific term, or you can write PPT as well. So if you want to separate silver chloride precipitate from mixture, the term silver chloride precipitate here refers to that silver chloride is in a solid form. Or we want to separate undissolved salt from mixture. So the techniques which we can use filtration, we can use decanting, and we can use centrifuging. Is it clear, the examples with the concept? That these are the techniques which can be used to separate the insoluble substances from the mixture, or a solid from the mixture: decanting, centrifuging, or filtration. Same way, if we want to separate soluble solute from solution, such as, like example, sodium chloride from aqueous sodium chloride. Aqueous sodium chloride means sodium chloride solution. So the technique which we can use evaporation, or we can use crystallization. If we want to separate the miscible liquids, that I will discuss in the next session. I'll end this session and share another link with you. Any question till now about the separation methods or techniques? Any question or a doubt?